Yes, dear children. Now let us see what is the role of common ion effect in the cation analysis or qualitative analysis. Okay, cation salt analysis can also be called as qualitative analysis. Now, the cations that you are going to find out in the salt analysis, it has been classified into 6 groups and 1 zero group. So together there are 7 groups, but we don't call it a 7th group, we call this as zero group. And which cation is there in that? Ammonium ion. Okay, and ammonium ion is the only cation which is a non-metallic cation, is it not? There is no metal here. Still it is a positively charged ion. Now apart from that, you have cations in the first group, Pb2 plus and Ag plus, and then in the second group you have Cu2 plus, Cd2 plus, As3 plus, copper, cadmium, arsenic. Then in the third group you have aluminium and iron. Then in the fourth you have zinc, manganese, nickel and cobalt. In the fifth you have calcium, barium, strontium, and in the sixth you have magnesium and potassium. Right? Okay. Now, this analysis, it is following the principle of common ion effect. How? Now I have given dilute HCl and H2S, NH4Cl and NH4OH. What are these? These are all called as group reagents. Like when you prepare, see, a salt is given to you and you are preparing the water extract of that. That means you take a pinch of salt, dissolve it in water, that is called as water extract. Okay, that is also called as original solution. Now to that original solution you add dilute HCl. Now when you add dilute HCl, then this Pb2 plus that is present in your salt will get precipitated as a white precipitate. Okay, same way in the second group, again the same way, the given salt is made in the form of a water extract and then it is treated with dilute HCl and H2S, and you get the corresponding precipitate of copper, cadmium and arsenic. So when you add these reagents, the cation in that particular group will get precipitated as a particular compound. Like in the case of first group, it will be precipitated as chlorides. In the second group, it will be precipitated as sulfide. In the third, it will be precipitated as hydroxide. In the fourth, it will be again precipitated as sulfide. Then fifth, it will get precipitated as carbonate. And sixth group cations, they will get precipitated as their phosphates or hydrogen phosphates. So this is how they are going to get precipitated, and these are all group reagents, right? Okay, now let us see how it is done. Now, in the case of zero group cation, what is done to find out? Zero group cation does not come under this common ion effect. It's a different thing. But then you need to know the cation analysis. That is why I have included zero group also. Now this ammonium salt is treated with sodium hydroxide and it is heated. Since it is an ammonium salt, on heating with NaOH, ammonia gas will come out. And this ammonia gas has a pungent odor, pungent smell, is it not? Now, when such a smell is observed, what you do is you dip a glass rod in concentrated HCl and bring it near the mouth of the test tube, from where ammonia gas is coming out. And it will give you dense white fumes of ammonium chloride. It will give you dense white fumes of ammonium chloride. This will tell you that your salt is an ammonium salt. Right? Now further, to confirm that your salt is ammonium only, what you do, you prepare the water extract of the salt, treat it with NaOH and then you add a specific reagent called Nessler's reagent. And if you get a brown precipitate, that means whatever you have identified as ammonium ion, it is confirmed, it is correct. What is this Nessler's reagent? It is potassium mercuric iodide, K2HgI4. You will be asked the formula of Nessler's reagent. You need to know. So this is your zero group analysis. It has nothing to do with common ion effect. Okay. Just systematic analysis I had to tell you. So I started with zero group. Now let's come to first group. Now in the first group, how do you do? Again, you prepare the water extract of the salt. That means a pinch of salt added to distilled water, and you shake it nicely, dissolve it nicely. Your original solution is prepared. Okay. Now remember, this water extract can be prepared only for water soluble salts. The salt should be soluble in water, only then you can prepare original solution in water. Otherwise, this original solution can also be prepared in dilute HCl. It can also be prepared in dilute HNO3. Okay, but for you people, you will be given only water soluble salts, so there is nothing to worry. Water extract is enough. Now, which is a group reagent there? Dilute HCl. You prepare the water extract of the salt and treat it with HCl, dilute HCl. Then the lead ion that is present in the water extract will get precipitated as its chloride in the form of white PPT. So if you get a white PPT, it is understood that your cation is in first group, and in the first group lead and silver are there. Obviously silver salt nobody will give you in the school, so it is lead. It is a lead salt. Okay. Now once you identify that, now remember, you should not add excess of HCl. If you add excess of HCl, what will happen? The white PPT that is formed will get dissolved. Okay. So in that case, you might miss your cation in the first group. ठीक है, अगर ज्यादा डाल दिया तो वो प्रेसिपिटेट आते आते डिसॉल्व भी हो गया. ठीक है. So what you will think? My cation is not there in the first group, but it would have come and it would have got dissolved because of excess HCl. So you have to be careful, right? Now once you identify that your cation is Pb2+, then you will have to confirm by other tests called as confirmatory tests. So these two tests, when you perform, it will confirm that your identification is correct. You can't leave it here. You have to continue to find out whether your detection of Pb2+ is correct or not. For that, you will have to perform confirmatory tests. So for Pb2+, one is done with potassium chromate, and the other test, it is done with potassium iodide, and you get yellow PPT. Now Pb2+ is confirmed. Okay. Now, in case by adding dilute HCl, if you are not getting any precipitate, that means your cation is not there in the first group. That means your salt is not a lead salt. Pb2+ का salt नहीं है वो. तो क्या करोगे? You will proceed with the second group. ठीक है. मेरा फर्स्ट ग्रुप में नहीं आया तो मैंने सेकेंड ग्रुप में आगे चलना है. तो क्या करोगे? ऑलरेडी आपने ओरिजिनल सोल्यूशन में HCl डाल रखा था, उसी के ऊपर आप H2S डालोगे. Now generally this H2S, it is prepared in a separate apparatus and it is generally used as a gas. But for simplicity's sake and to avoid wastage of chemicals, what we have started is, we have started giving this H2S by giving sodium sulfide to the children, and when you treat this with water, H2S will be formed, and that H2S is used in the reaction. Now since your Water extract, it is already prepared in water. You need not add water again. उसमें आपने डाइल्यूट HCl डाल रखा है, आपका प्रेसिपिटेट नहीं आया, ठीक है? तो उसी के ऊपर आपने 1 or 2 flakes of sodium sulfide डालोगे. If your cation is in the second group, then you will get either a black PPT or yellow PPT. अगर आपका सॉल्ट कॉपर सॉल्ट है तो ब्लैक पीपीटी आएगा, अगर कैडमियम या आर्सेनिक है तो येलो पीपीटी आएगा. ठीक है? क्लियर सो फार? नाउ HCl is already added in your water extract. To that you are adding H2S. So this H plus is common. तो कॉमन आयन क्या करता है? सेकेंड इक्वेशन को अगर ये कंज्यूम हो गया, if the because of common ion what will happen? The dissociation of H2S is depressed, is it not? Excess of H plus ions are there, so the reaction will move in the backward direction. So more and more of unionized H2S आपको मिलेगा, is it not? So if it is moving in the backward direction, the extent of S2 minus in the medium will be less because H plus की common ion की वजह से reaction backward शुरू हो जाएगा. In that case, these two will react together. That means S2 minus will also get reacted with this. Okay, so the extent of S2 minus in the medium is less because वो backward में जा रहा ना. But कम होने से भी ये कॉपर, कैडमियम, आर्सेनिक, they are precipitated as their sulfides. Why? Because we have seen this condition whenever ionic product is exceeding solubility product, then precipitation occurs. This you have studied, we have done this topic. Precipitation occurs if this condition is fulfilled, if IP is greater than KSP. ठीक है? IP is depending upon the extent of S2 minus in the medium and the metal cation Cu2 plus or Cd2 plus in the medium, right? And KSP is a standard value at a particular temperature. Now, in the given medium, if the ionic product exceeds KSP value, which is a standard value, then precipitation will occur. And they have found that for these cations, the KSP value of the sulfides of these cations are very, very low. Okay, so in spite of S2 minus being less in the medium, still the ionic product will exceed KSP because KSP is very low. तो जितना भी S2 minus मीडियम के अंदर प्रेजेंट है, Cu2 plus into S2 minus की जो आयनिक प्रोडक्ट है वो उस सल्फाइड की KSP वैल्यू को जरूर एक्सीड करेगा और एक्सीड करने से प्रेसिपिटेशन जरूर होगी. ठीक है? सो दिस इज हाउ प्रेसिपिटेशन इज डन.